I'm going to start from a place where we assume you have an editor of choice and have opened up a fresh file. For right now, we're not too worried about anything else other than just the ability to type some code on a screen, even if it's just to observe it and see it. But hopefully you have an editor. Use Google and other resources to get caught up there if you need to. And so we'll get into our token here. Okay, so the very first thing we're going to do, we're not going to talk a ton about it. Okay, so what did I just put there? SPDX license identifier MIT. Okay, MIT is just denotes a public permission open license for writing Solidity. Okay, when I add those two slashes right there, it allows me to be commented out, or essentially leave a note to myself or other people who might read this code. Okay, in our second line, we're going to write pragma Solidity. And we're going to say that we want to use at least 0.8.0, and that's telling us version-wise that we want to make the Ethereum virtual machine to be reading according to its version at least 0.8.0, and it will do that without fail. Yep, we want that there. Okay. All right, wonderful. So let's talk in general about a token. Okay. So I'll admit we're not yet coding out our DPN token. We're just going to talk about a contract that is a token of the type ERC20. Okay, so write contract token there. Now, there's certain characteristics when you see that ERC20, and this is what provides your security as an investor. If you buy Bonk, you know, it has a name and a symbol. It's got decimals and a total supply. You know, if it didn't have those, you're really in the Wild West with crypto, because you could, you know, have something where they're just minting 1 million every day, and you find out about that later, or you find out the decimals are weird, you don't have as much as you thought, or a token that has, you know, not a clear name and symbol. Obviously, that's a problem. So just to start out, let's just write those characteristics followed by a semicolon. Any ERC20 is going to have a name. It's going to have a symbol. It's going to have decimals that are public, and we'll see what that means later. Okay, and it's going to have a total supply. Okay, and we'll go ahead and bring our decimals into a standard, which is 18. What's key about the decimals is it's telling us how this token fractionalizes itself. And so to use Ethereum as an example, 1 way, which is the tiniest unit of Ethereum, is a decimal followed by 17 zeros and a 1. Okay, so 18 decimal places. And so it's offering essentially a scale. We could almost look at it as a scale for how we are dividing up that token. Okay, so let's come look at these further. And the name, well, what's the name going to be made up of? It's going to be made up of a series of letters, okay, or numbers, in our case letters, and that in Solidity is called a string. Okay, secondly, it's going to be public. That's a promise from an ERC20 standards, is saying, hey, we're going to make sure that this token has a clear name and it's public for anyone who on the blockchain to look at. Okay, the symbol similarly is going to be typically a series, in our case, series of letters. So again, that's a string. It's going to be public in terms of visibility. Okay. Now, decimals is going to come in a number form, right? And so let's talk about numbers. Numbers in Solidity are uints. Okay. And we're going to use uint 256, and I'm just putting this down here low because to me, I always thought of it looked like a little bit of a pickup truck with numbers in the back. Okay, so when you think of numbers, we have a little pickup truck coming, and it's going to be public as well. So that's, you know, it's and the total supply is numbers as well. And I think what's so important about that is this public part. It's like this is our promise to you. If there's a token called an ERC20, it's going to have these characteristics. A public name, public symbol, a public decimals. How are we dividing this up? What's the smallest amount you could purchase? And then finally a total supply. Nobody wants to buy a token or be earning a token that's just pouring out of the mint, right? Then it's not worth anything. Okay, so we're getting there. Very good. So now we come to our constructor, which happens one time. This function takes place one time upon deployment, okay, of our contract. And so we're saying inside of here what it is that we're going to be constructing. We are going to construct a string. We're going to store it in memory, and it's going to be called name. Now notice I put the underscore there because this is going to be a local variable. We're going to tie it to these state variables. And finally, our total supply, okay? And then we're going to put that in memory as well. Okay? Separated by commas. And again, we're in a generalized token at the moment, but here's what here's the information this constructor is going to establish, and here's what it's going to establish it to, essentially, is what's in the function body. And that is namely that we're going to connect the name with our local variable name, symbol, tying it to our local variable symbol to come, okay? Okay, so total supply, we're linking that to our local variable total supply. And just so we can understand it, we need to add a way to convert those decimals, okay? So just bear with me. Okay? And so congratulations, you've written a very basic ERC20 token contract, okay? And I wanted to go through that exercise because what we're going to do is essentially package this up and receive it from an organization that has tried and true contracts that are available open source called Open Zeppelin. And we're going to inherit their ERC20. And that's simply because if you looked at this as a structure that we built, let's say that we just built a storage shed in your backyard. Well, there's a company down the road that has just incredible storage sheds. It's been around for years. We know they're strong. They will stand a tornado. They've been tested and vetted. And so what we're going to do is just nicely come along here and just up to the pragma. Let's go ahead and hit delete, okay? Because now we're going to actually code out our DPN token. So let's do that now. So we're going to write contract. What's the contract for? It's for the DPN token, okay? Now, here's where the fun part comes in of getting that wonderful secure contract from another provider is we're going to import from Open Zeppelin, okay? Put some quotation, they both come in there, okay? So where is the import going to come from? It's going to come from @Open Zeppelin contracts. What kind of contract? Token contract. What kind within token? Oh, ERC20. And then specifically the ERC20.sol. And that is denoting .solidity, i.e. the language of the Ethereum virtual machine. And so we come back here I know I'm kind of going in an interesting order, but contract DPN token, well, how do we inherit that? Well, watch this, is ERC20. Okay? Simple addition of code. Our contract knows, just like you can walk into a place with your big tough dad, or maybe you are a big tough dad. Hey, he's with me. Okay, this is saying, hey, DPN token is ECR20. It's inheriting all of the characteristics, all of the security, and everything that comes along with this wonderfully vetted and tested, battle-hardened ERC20 contract. Okay, you can go to OpenZeppelin and look at those yourself just to learn more. So we're going to go right to our constructor, and our constructor once again is run one time at the deployment of the contract, rather. Okay, and we're going to argue one thing. We're going to argue the initial supply. Okay, so this is us saying, hey, we're going to argue a number which is initial supply. And we're going to argue that these be connected to ERC20, okay? And in this case, like, remember, we have inherited this DPN token is ERC20, okay? And I need to fix a mistake here. We need to run this space back here, okay? Apologies there. We got that fixed. All right. So we're going to mint an initial supply of the ERC20, which is DPN token, and we're going to call it DPN token, comma, and its symbol DPN. Okay. And that simply comes from the requirement that argument. We're arguing that an initial supply of ECR20 be deployed, and we need to state at that time that that name and symbol. Now, our initial supply amount and other things will be taken care of in our deployment script. One of the functions available to us from the OpenZeppelin contract is a mint function, and so we are going to call that mint function _mint. We need to argue who is going to get that minting and what the minting is. It's going to be the initial supply, okay? So message sender and initial supply. Okay, congratulations. You've written your first contract, okay? And let's go just over those little elements one more time. We've got our license identifier, which it just specifies the license under which the contract is distributed. This is a permissive open source license, MIT. Solidity version. This line specifies the version of Solidity that the contract is written in. It's saying, hey, at least use this version, okay? Our import is importing OpenZeppelin contracts. Well, which one? The token, the ERC20, and particularly the ERC20 contract, okay? And then contract DPN token is ERC20. It's defining a new contract named DPN token that inherits from its father or mother, the ERC20 contract characteristics from OpenZeppelin. That means that the DPN token has all the functionality of a standard ECR20 token. Okay, and then once again, the constructor, which happens one time upon deployment, is deploying the initial supply to the message sender. And so message sender is always you, or it's the sending wallet. Every interaction on the blockchain is tied to wallets. And so it's minting the initial supply, which will be determined in our deployment script coming up. We could do it here just once and for all, but we'll do it in our deployment script and send it to the message sender, okay? So congratulations, you wrote your first smart contract. If you stick with me, we're going to set up our environment. a very basic stack or project where we can test within the Hard Hat system. Hard Hat provides an environment where we're essentially within the Ethereum virtual machine able to move tokens and money around without it being real money. So it just makes the functionality practical. We're going to write a test and see just how this contract stands up and works as we head towards the building of our complete DPIN simulation system. All right, join me next time.